Ever wondered how a machine can emulate human intelligence? Imagine a world where machines can think, learn, and make decisions just like us. How is this possible? What kind of technology enables a computer to recognize your face or a virtual assistant to understand your voice? And what about the implications? Can machines truly become as intelligent as humans or even surpass us? These are the questions we'll delve into as we explore the complex and intriguing realm of artificial intelligence. Welcome to the fascinating world of artificial intelligence. To understand AI, we need to travel back in time to its inception. It was the 1950s, a period marked by the rapid evolution of technology and innovation. Amidst this technological boom emerged the concept of artificial intelligence. The term AI was coined by John McCarthy, a young computer scientist, during the historic Dartmouth Conference in 1956. McCarthy, along with a group of scientists, proposed the revolutionary idea that every feature of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. But even before McCarthy, there was another key figure who laid the groundwork for AI, and his name was Alan Turing. Known as the father of modern computing, Turing proposed a simple yet powerful question: can machines think? This question led to the creation of the famous Turing test, a method of inquiry in artificial intelligence for determining whether or not a computer is capable of thinking like a human being. The Turing test was simple. If a machine could carry on a conversation that was indistinguishable from a conversation with a human being, then it was reasonable to say that the machine was thinking. This test laid the groundwork for future AI research, setting a benchmark for what constitutes intelligence in a machine. The Dartmouth Conference, on the other hand, was a meeting of the minds that further propelled the development of AI. It was here that the pioneers of AI gathered to draft its fundamental principles and set its future direction. The conference was marked by an atmosphere of optimism and the belief that machines will eventually be able to perform any work a human can do. Thus, in the 1950s, with the Turing test and the Dartmouth Conference, the foundation of artificial intelligence was laid. It was the dawn of a new era, the era of machines that could think, learn, and adapt. It was the dawn of AI. Thus, the foundation of artificial intelligence was laid. But not all was smooth sailing in AI's journey. While the initial excitement about artificial intelligence led to many promising developments, there were periods where progress seemed to stall. These periods are known as the AI winters, characterized by a significant reduction in funding and interest in AI research. The first such winter occurred in the mid-70s when it became apparent that many of AI's early promises were dramatically harder to fulfill than initially thought. The hype around AI had painted a picture of a future filled with autonomous machines capable of outsmarting humans. However, the reality was that the technology was in its infancy, and the challenges were more significant than anticipated. The gap between expectation and reality led to disillusionment. Funding dried up, research slowed, and AI entered its first winter. A similar pattern repeated in the late 80s. Once again, the hype outpaced reality, leading to another AI winter. This time, the disappointment was due to the limitations of expert systems, which were the leading AI technology of the time. But just like the seasons, winter eventually gave way to spring. The 90s and early 2000s saw a revival in AI interest and funding. This resurgence was fueled by two significant developments: the rise of the internet and an increase in computational power. The internet provided a vast amount of data, and AI thrives on data. It offered countless opportunities for AI to learn, grow, and prove its value. Meanwhile, advancements in technology led to more powerful computers, enabling more complex calculations and supporting more sophisticated AI models. These developments opened new avenues for AI, leading to significant progress in areas like natural language processing, machine learning, and robotics. The winter was over, and AI was back in the limelight. As we entered the 21st century, AI was about to take a giant leap forward. In the present day, AI isn't just an idea, it's a reality. Our journey into the realm of artificial intelligence now brings us to its modern incarnation: machine learning and deep learning. Let's demystify these terms a bit. Machine learning is essentially a subset of AI that allows machines to learn from experience. It's like teaching a child to recognize shapes. You show them a circle, a square, a triangle, and over time, they learn to identify these shapes on their own. Similarly, machine learning algorithms learn from data and improve their performance over time. Deep learning, on the other hand, is a further evolution of machine learning. Picture it as a multi-layered neural network, much like our own brain, capable of processing an enormous amount of data, identifying patterns, and making decisions. Now let's bring these concepts to life with some examples. Think about when you're browsing a streaming service and it suggests a film you might like. That's machine learning at work. The algorithm has learned your preferences based on your viewing history and is making recommendations accordingly. Or consider voice assistants like Siri or Alexa. These marvels of modern AI can understand your voice commands, answer questions, set reminders, and even tell jokes thanks to deep learning. They process your speech, understand the context, and provide an appropriate response. And let's not forget about self-driving cars. These vehicles use both machine learning and deep learning to navigate roads, recognize traffic signs and signals, avoid obstacles, and get you to your destination safely. All these examples illustrate how AI is no longer a distant concept from science fiction. It's here, it's now, and it's woven into the fabric of our everyday lives. From entertainment to communication, from driving to shopping, AI is quietly working in the background, making our lives easier and more efficient. From being a mere concept in the minds of visionaries, artificial intelligence has come a long way. It has become an integral part of our daily lives, revolutionizing industries and reshaping the way we interact with the world. Today, AI is everywhere around us, making our lives easier and more efficient. So, what does the future hold for AI? As we gaze into the horizon, we see the possibility of a world where artificial intelligence has evolved into something much more comprehensive and sophisticated: artificial general intelligence, or AGI. This is a type of AI that could understand, learn, and apply knowledge across a wide array of tasks, much like a human would. It's not just about playing chess or recognizing faces anymore. We're talking about AI with the ability to comprehend complex systems, create original ideas, and even understand human emotions. But, as with any technological advancement, it's not all sunshine and rainbows. The development of AGI brings with it a host of challenges. For starters, creating an AI with human-like intelligence is a monumental task. It would require massive leaps in our understanding of both technology and the human brain. And once we've created such an AI, how do we ensure it behaves ethically? How do we prevent it from being misused? These are questions that we, as a society, will have to grapple with. But let's not forget the potential benefits. AGI could revolutionize every sector of our lives. It could solve complex problems that have baffled humans for centuries, like climate change or curing diseases. It could take over mundane tasks, freeing up time for humans to engage in more creative and fulfilling endeavors. The possibilities are truly limitless. Yet we must tread carefully. The future of AI is not predetermined. It's not something that will happen to us, but something that we will shape with our choices and actions. We must ensure that the development of AI is guided by a commitment to the betterment of all humanity, not just a privileged few. The path to AGI is fraught with challenges, but it also holds immense potential. It's a journey that we, as a society, will embark on together. And as we do, we must remember to keep our eyes on the prize, a world where AI serves us, not the other way around. The future of AI is as exciting as it is uncertain. So, we've taken a brief journey through the world of artificial intelligence. We started at the very beginning, where the seeds of AI were first planted. We explored its inception, born out of a dream to create machines that could think and learn like us. From there, we navigated through the ebbs and flows of AI's development, witnessing its periods of growth and stagnation in what is often referred to as the AI winter. We then delved into the resurgence of AI, fueled by advancements in computational power and the advent of machine learning. We saw how these modern AI systems are now embedded in our everyday lives, powering everything from our smartphones to our cars to our healthcare systems. Looking ahead, we speculated on the future of AI. It's a future that's both exciting and uncertain, filled with potential and challenges. But it's a future we're actively shaping every day with our ideas, our innovations, and our ethical considerations. In the end, artificial intelligence is not just about technology. It's a reflection of us, our aspirations, and our human ingenuity. It's a tool that, when wielded wisely, can help us solve complex problems, make our lives better, and perhaps even unravel the mysteries of the universe. Thank you for joining us on this journey through AI. Remember, the only limit to AI's potential is our imagination.